Alright, so let's look at a couple of questions now. The first question is a very, very easy question. What we're trying to do over here is that we're trying to represent the first statement and the second statement and then look for the possible solutions for these questions. Okay, so let's look at the first statement over here and try and represent it as a Venn diagram. It says man is a van. Now don't get confused, okay? You don't have to do anything. Yes, they look weird. Yes, they're looking nonsensical. Remember what I told you in the beginning of the class. But then we've got to only remember our rules, right? Now you'll say, Sonal, there's no all, there's no sum over here. So how do we represent this? Remember it as a rule. If there is nothing given, then it is all statement, right? So when we say man is a van, what we mean is that all man is all van. Okay, so let's try and represent this. How are we going to represent it? All man I'm sorry. Is van. Perfect. So all man, man inside, van outside, man might just be a subset of it. Now you say, you know, Sonal, why haven't you drawn two overlapping sets? Now you don't have to draw them to remember them. Just keep it in over here, right? We're drawing those statements. You'll carry that. You realize this towards the end of the class, that we draw only those representations that lead us to the negation of maximum possibilities. Okay, this statement is going to make more sense to you as soon as we progress into the class. Let's draw the second statement, which says all van is a vehicle. All van is a vehicle. I'm choosing a different pen for this. Let's see how we can represent this. It says all van, the entire van is a vehicle. Yeah, what we're trying to say is van inside, vehicle outside. I'm sorry, I haven't been able to complete that circle, but then imagine, or let me just draw it again. Yeah, this is man, all man is a van, and it says van is a vehicle, right? Perfect. Now let's look at the possible conclusions. What you have to do is see if they are true. Okay, some vans are men. It says some vans are men. The ones that are inside this area, those vans are men. Yes, of course they are. So this one is true, right? Let's look at the second one. Let's look at the second conclusion. It says some vehicles are men. Of course, some vehicles are men. The ones again inside this, those vehicles are men. Perfect. This is also true. Let's look at the third one. Man is a vehicle. Man inside, vehicle outside, which is true. Yeah, perfect. Man is a vehicle. Perfect. Third one's also true. Let's look at the fourth one. Some vehicles are not men. Some vehicles are not men. Yes. These vehicles that are outside man, as well as these vehicles that are outside man, those vehicles that are not men. Absolutely. Therefore, the answer is going to be D, all follow. No, this is not what the answer is going to be. If you've already got the answer, bravo. The answer is only 1 to 3. Why wouldn't this statement follow? Let's look at it, okay? this statement wouldn't follow, because remember, there is one more possible representation of the all statement. When you say all man is a van, there's a perfect possibility that all man is a van, m is equal to v. All of man is a van, two superimposing sets, two overlapping sets, right? Man is equal to a van. And when you say a van is a vehicle or all vans are vehicles, possibility that these were nothing but three overlapping sets that were same in size, constituencies, shape, everything. Which brings us to the fact that if m is equal to v is equal to v, that is, which is man is equal to van is equal to vehicle, there's absolutely no scope for statement number 4, which is some vehicles are not meant to be true. Did you understand? So when I said you will draw those representations that cancel out most of the other representations, or they cancel out most of the other possibilities, what I mean to say is that keep the obvious ones in your head at least, right? You're supposed to draw the one that gives you the maximum possibility of an answer, but remember that there is a scenario like this as well. There's a scenario when three overlapping sets or two overlapping sets might be there, which would negate possibilities of a not statement from being there. Did you understand? Let that sink in with you. Let that sink in that when we have the all statement, we have absolutely no scope for a not statement to come in as a conclusion, right? Therefore, the answer is going to be only 1, 2 and 3 follow, right? Good question, right? Great.